we're going to build our differentiator amplifier, and then also we're going to build our integrator circuit. So basically how our differentiator amplifier works is that if you give it a sine wave, it will give you the derivative of the sine wave, which is actually the cos wave on the output. So, and the integrator will do the same thing, will integrate the sine wave, and then it will give you the integrated signal on the output. So what's going to happen is that I'm still using the same IC, the 741 IC. I'll just put it here, and this one I can use it for my differentiator circuit, and therefore I can put the other one this side, which is going to be for my integrator circuit. I'm just gonna put them there, a bit close, and then what I'm gonna do, I need a 47 microfarads, which is actually the one that I'm holding now, and it's going to the negative one, which is actually pin number 2. So I'll just put it like this. That's where my input will go, so I'll put it like that. It's going to be the input here. Therefore I can connect the wire here, so that's going to be the input, and therefore I need to connect my 10K from pin number 6 to pin number 2. So I'm going to connect it here on pin number 6 to pin number 2, connect it like this. That is my feedback resistor, pin number 6 to pin number 2. Therefore it's fine there, and then I need to just connect the wire here on pin number 6 to check my output, and therefore I need to connect pin number 7 to my VCC. So pin number 6 actually it will be here, so I'll just take this one out and then put it there. And then now I'm gonna put pin number 7 here to the VCC. I can actually connect the other wire here from here, just to connect it to pin number 7 of the other IC here. And therefore now the other thing that I need to do is to connect pin number 4, and then on pin number 4 I'll take it to ground. So this is pin number 4 here, I'll take it to ground on the other side here, and then I need to put the other one this side. It's going to be for the VCC, and then this one will be for ground, and then I'll just take this one, put it here. That's going to be for my ground, with the ground, and then I'm actually done with my inverting. And then now I can go to my I'm done with my differentiator. Then now I can actually go to my the integrator. If you look at the integrator this side, it's actually this side. I'm gonna connect this resistor here, connect it to pin number 3, connect it to pin number 3, and therefore have the input there. Going to be the input there, put it here, and therefore take my capacitor there, and therefore put it from pin number 6 to pin number 3. So I'll take it from pin number 6 actually to pin number 2, not pin number 3, so it will be going to pin number 2. I'll put it here on pin number 2 this side, pin number 2 this side, and therefore I'll take pin number 4 down to ground, take pin number 4 down to ground. And then that's actually how you are going to do it. That's the input, and then I need to put the other wire here for my output on pin number 6, and then put it there. That's going to be my output. So that's actually how you get to connect the circuit. Right, so we've got our differentiator circuit this side, and we've got our integrator circuit this side. Remember, with this one, when I give it a sine wave, it will, or when I give it any input, it will give me a derivative of the particular, of that particular input, and then on the output I'll see the derivative. So if I give it a sine wave, it will give me the derivative of sine, which is actually going to be a cos function, and then the integrator will do the opposite of that. It will integrate. In other words, if I give it a cos function, then I'll get a sine, and then that's how it's going to work. So now I'm just going to connect the circuit here. I'm having my 741 op amp. On the input here, I've got the resistor and the capacitor, and then I've got a feedback resistor this side. And then when I come to my integrator here, instead of having the feedback using a resistor, I'm using a capacitor as a feedback, and then on the input here I've got a resistor. So now what's going to happen is that I'll connect this one, which is actually my differentiator circuit. You can see on my power supply there, I've put it on a series mode because I need a negative and a positive voltage. So I'll take my common, which is actually this one. Okay, I can just start with this one first. Therefore I'll put it here on pin number 4. That's for my negative voltage. And then now I'll take my this other one, which is on pin number 7. That's my positive voltage there, and therefore the rest is going to be taken to ground. That's going to be my output, so I'll use the signal, the oscilloscope to measure it. Right, so now you can just take this on the side, it's fine. And then I'll take the input and then put it here on the oscilloscope, this side. The input from my signal generator. Therefore this is my pin number 3. I'll take it to ground. So that's pin number 3 to go to ground. There's the input there, then I've got my ground connected there. And therefore I can take this one, which is actually the common, I can put it also there, my ground. And then now everything has been connected, it's fine. So I need to put my measurement. I'll take from the oscilloscope here, I've got the yellow one there, which is channel number 1. It's going to be my input. It's always important to have your input on the oscilloscope, just to see if you are really giving it a wave, because at some point you might be looking for the output only to find that you don't have the input. So I'll just take this one here. It's actually my input. I'll take this one and then put it here. That's the input there. It's actually going out, so I can actually put it here. That's fine, and then make it a point that this resistor is in. And then I'll take this one this side and I'll put it on ground. Okay, so it will be like that. That's the input, and you can even already see that on the oscilloscope there, it's flickering, showing that there is something, meaning the connection is actually underway. So I'm gonna connect this one here on the output. That's pin number 6 on the output, and therefore I'll take the other one here to ground. Take this one this side. Just put it nicely there. And actually put it on top of this one. That's actually my ground. Okay. So what's going to happen is that I'll just give it power there, and that's on 8 volts, and then I'll just try to give it an input there, input this side, and I'll give it sine wave. Right, if I give it a sine wave there, then just try to adjust the voltage per division, take it to 2 volts, and then let me put all of them on the same axis, the axis there, and then I'll just try to take this one a bit up. right? So you can see that if I give it a sine wave, then it's giving me the output as a cos. So the output is actually the blue one, so you'll see there's a cos function, and then I'm giving it a sine function. That's actually how it works. So that's my differentiator. So it is giving me the derivative of the other one. So that's actually how you get to work on it. And then now, after doing that, then I'll just go to my other circuit. I'll just switch on my power supply there, and then switch off also my signal generator there, and then try to disconnect them here. Let's try to disconnect this one here. That's my oscilloscope this side, and then also try to disconnect this one from the oscilloscope, put it on the side there, and then also take out the probes for my power supply. Take this one here. Excuse me. And therefore just put it this side, it's fine. Therefore I'm having the other one. This one is going to be the integrator, so it will integrate any function that I give to it, and I'll get the integral on the output. So I'll give it an input here from my signal generator, and therefore I'll just take this one here. That's going to be the ground point, and just put it here. Therefore I can take the ground one, put it there, make sure to put it on the side, it's fine. Therefore I'll take the positive voltage there, put it on my pin 7, and therefore this one is going to be the output. I'm gonna use the oscilloscope. That's going to be my output here, so I can actually put it there. There's the output here, and like before, red oscilloscope, it's showing you that there's some detection there. So I can take this one and also put it on ground side. Positive voltage is connected there, and therefore one is fully connected. So I need to measure also, put my, so it's going to be the output. I can actually take it to the input side, so it's fine. I can take this one and then put it here on the input. I can put it there, so that I can have channel number 1 on the input and then channel number 2 on the output. So I can put it somewhere there, and then connect it with the ground the side, and therefore now I need to measure the output, which is going to be this one over here. It's going to be the output there. Put my output here, and then I also put it like that. So that's basically how you are going to be connecting your circuit. Remember, now this one is an integrator, so we're just gonna see the output and then see how it works. Okay guys, where we left off, remember I connected my power supply, that is my integrator circuit, and I've got my oscilloscope there. The yellow one is going to be the input and the blue one is going to be the output. And then now I've got my signal generator. That's where I'm going to be taking a wave or a function or an input and just giving it to my circuit and see if I'll get an integral. I'll get the integral on the output. So what I'll do, I'll just switch on my power supply there, and then go to my signal generator, switch it on there, and then already you can see that just by giving it a sine wave as the input there, on the output I'm getting the cos there, right? And then let's try to give it a different wave, and then you can see there I'm giving the square wave, and then I'm having a rectangular wave on the output. So that's actually how the integrator works. You give it a certain wave on the input, and then on the output it will give you the integral of that particular wave that you used on your input. So that's how the circuit works.